Nancy's at Home Learning Series for Math. Today's lesson is for all third grade out there, though all children are welcome to tune in. This is lesson number 13 in a series. My name is Lisa Sharkley, and I'm a third grade teacher at Venus Stewart Elementary in Gallatin, Tennessee. I'm excited to be your teacher for this lesson. Welcome to my virtual classroom. If you didn't see the previous lessons, you can find it on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson if you hadn't seen any of the others, but it might be more fun if you go back and watch our other lessons since I'll be talking about things we've learned previously. Today, we'll be learning about using unit squares and multiplication to find area of squares and rectangles. For you to fully participate, you need a sheet of paper and a pencil. Okay? Are you ready? Let's begin. We'll start off with some vocabulary. Lesson 13, area, key vocabulary words. Will you say them with me as I say them? Unit square, multiplication, area, length, width. We'll be using these words in our lesson today. Let's solve a problem to review finding area using standard units. On your paper, write a definition for area. When you hear that word area, what do you think of? Write a quick definition. And I hope you wrote area is the space inside a shape. Okay? How do we find the area? How do we find the area? I see you thinking. How do we find that area? We find the area by counting the square units inside of a shape. And my last question to get you warmed up. What is the area of the shaded rectangle? What is the area? Start thinking, how can you find out what that area is? All right, I can find that area by counting all the square units that are green. I'm just going to count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. 24. My area of this green shape or green rectangle would be 24 square units. All right, second question. Still getting warmed up. Is the area of a rectangular desk more likely to be 8 square feet or 8 square inches? Now, in our previous lesson, I showed you square inch, that size. A square foot, this size. So, if I had to find the area of a rectangular desk, which would it most likely be? 8 square inches or 8 square feet? Do your thinking. And I bet you were saying 8 square feet. If you had it, give yourself a lasso cheer. All right. Let's keep it going. I'm going to do my quick erasing. Today, we're going to continue finding the area of squares and rectangles, but we're going to consider if there's another operation besides addition that can help us. Here's my first word problem. Read it with me. Asia is carpeting 2 rooms. One room is a square with a side that measures 6 meters. The other room is a rectangle with sides that measure 3 meters and 12 meters. How many square meters of carpet does Asia need? How many? Okay. There are different ways we could have come up with our answer for that one. And I'm going to show you one, just to keep us thinking. Let me show you how a student named Shelley found the area of the first room. This was her thinking. So I'm going to step here and kind of point. Shelley drew her square and labeled two sides with a length of 6 meters. So she did her square, 6 meters, 6 meters. We were given that side length in the problem. Next, Shelley made a connection to multiplication where she learned to draw area models with rows and columns to solve multiplication problems. She saw each row as a group of 6 unit squares. She knew she had a total of the 6 groups. This reminded her that she could use multiplication to find the area. So by using multiplication, Shelley also determined the area of the square to be 36 square meters. So I can count the unit squares to find area, but I can also multiply the side lengths. Now we need to find the area of the rectangular room. Draw the rectangle so that its short side is 3 meters and its longer side is 12 meters. Draw unit squares to cover the rectangle and then find the area. Okay, so let's do some drawing. I'll draw it with you. 3 meters. So I need to make 3. Okay, now 12. I need to make 12 pieces. Let's see. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let me recount. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. 1, 2, 3. Now, to find the area of this rectangle, I could do my dots and count each one, or I could think of multiplying. To find area, I can use this formula. Length times width. That's the formula you can use to find area. Length times width. My length is 3 times my width is 12. 3 times 12. I can count by 3s. We've practiced that. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. My area would be 36 meters. That was, I think, easier than counting each square using multiplication. Let me show you how my student Cal answered the question. Cal counted by ones and wrote the number of the count in each unit square to keep track of his counting, which is a great strategy. Cal also recorded that he got 36 square meters like we did. It's very important to record both the number and the standard units. So, whether you use addition or multiplication, we both arrived at 36 square meters for the area of that rectangular room. Both of the rooms that Asia wants to carpet have an area of 36 square meters. To find the total square meters of carpet that Asia needs, we need to add the 2 areas together. 36 meters plus 36 square meters equal 72 square meters. Asia needs 72 square meters of carpet to cover both of her rooms. Let's work through another area problem and think about how we can count unit squares or multiply to find the area. Now we have a student named Garrett in this one. Hi, Garrett. Garrett paints a rectangular wall in his room green. Okay. The picture shows the length and width of Garrett's wall. A small can of paint covers 40 square feet. Does Garrett need more than one small can to paint the wall of his room? Start doing your thinking. Does he need? I think first I need to figure out the area of his wall to decide if 40 square feet will be enough. I'm thinking about that. To find area, I can multiply the length times the width. So I can multiply my length, 8, times my width, 6, to see what is the total area of his green room. Okay, let's do some skip counting. We like to skip count. All right, 1, 2, 3, 4, 5, 6. I think it might be easier to skip count with 6 to find it. 6, and I'll write it as we're saying it. 6, 12, 18, 24, 30, 36, 42, 48. So 8 times 6 equals 48. So the area of his room is 48. Oh, let's see if it told me. 48 square feet. Square feet. Now I found out the area, but that's not the question. The question is, does Garrett need more than one small can to paint the wall of his room? If the area is 48 and one small can has 40, does he need more? And I hope you're saying yes. One can would not be enough. He needs either 2 small cans or a larger can to cover it. Let's apply this learning to an area problem where we don't know the length of a shaped side. Listen as I read the problem. The area of another wall in Garrett's room is 56 square feet. The wall is 8 feet high. How wide is the wall? So they've given me my total area. Wonder if I can write this into a multiplication equation. What do you think? I think I should. I think I should use, let me write area. I want to keep reminding us, area equals length times width. So if I know my length is 8 times, I don't know my width, equals 56. I have to think, what would go in that blank? Could I skip count by 8s till I got to 56? And no, I could. So I could say 8 times 1 equals 8. 8 times 2 equals 16. 8 times 3, 24. 8 times 4, 32. 8 times 5, 40. I'm getting close. 8 times 6, 48. 8 times 7, 56. And that goes back to that trick. 5, 6, 7, 8. When you see that 8 times 7, think about that trick. 5, 6, 7, 8. All right, so how wide is the wall? My answer would have to be 7 square feet. And we made a multiplication equation to find the area. All right, we're still going. I'll do the first practice problem. Find the area of the square. Okay. I think I'm going to write a multiplication equation to help me. I'm thinking of how many rows are going down, how many are going over. Because to find area, length times width. All right, here we go. 1, 2, 3, 4, 5, 6, 7. I have 7 for my length. Times, let's find the width. 1, 2, 3, 4, 5, 6, 7. Oh, that's a perfect square. 7 times 7. All right, can we skip count by sevens? Yes, we can. I'll write it right here as we go. Say it with me. I'm listening. 7, 14, 21, 28, 35, 42, and what's that last number? Yes, 49. 7 times 7 equals 49. So, my area of this square would be 49. Oh, make sure I label it square centimeters. Give yourself a round of applause for getting that one. Now I'll work a problem that has a missing side measure. Just like we did earlier, I'm going to use my multiplication strategy of area equals length times width. Now they've given me the length 5 times, I don't know what the width is, I'm putting a line, equals 20. All right. I'm giving you time. I bet you're already saying it, but Sharkley, I agree, it is 4. 5 times 1 equals 5. 5 times 2 equals 10. 5 times 3, 15. 5 times 4 equals 20. 20 what? Let's make sure we label it, or 4 square feet. 4 square feet would be my answer to this problem. Find the area of the shape. Should we use multiplication? We can. Or we could count each one, but we've really practiced using that multiplication strategy. I think it's a great strategy to find area. All right? Let me write it up here again. I don't want us to forget it. Area equals length times width. All right, let's find our length. 1, 2, 3, 4, 5. Let's find our width. 1, 2, 3, 4, 5, 6, 7. Okay. Giving you 10 seconds. 10 seconds is all it's going to take. 10 seconds. 4, 3, 2, 1. Beep, beep, beep. What's your answer? Yes, 35. Don't forget to label it square centimeters. And I'm going to abbreviate like they did. Square cms. That would be the area of my shape. Let's try another area problem with a missing side length. All right, turning it right into a multiplication problem. They've given me my length, 6. Ooh, let's make that a better looking 6. Times, I have a missing factor, and they've given me the product of 42. So you have to think, how many 6s does it take to get to 42 to find the missing factor that will help us with our area problem? Giving you just a couple. Think, think, think. minutes. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. 6 times 5 is 30. 6 times 6 is 36. 6 times 7 is ding, ding, ding. 6 times 7. My answer should be 7 square, and the M stands for meters. That would be my missing side length. Okay, let's keep going. We're on a roll, doing great. Now you try these two problems by yourself. Find the area of the shape on the first problem and use multiplication to find the missing side length. These will be our last two practice problems together, okay? So let me say this is your number 1. This is your number 2. I'll step out, giving you 30 seconds, okay? Go ahead and begin. All right, let's look at this one. I think I'll use a multiplication problem to help me. Area equals length times width. So 1, 2, 3, 4, 5, 6. 6 is my length. Let's find our width. 1, 2, 3, 4, 5, 6, 7, 8. And 6 times 8 equals, yes, 48 square feet. That would be the area to my rectangle. The last one, I had to find the missing side length. So it did not give me the length. So blank times my width is 8 equals a total number of 64 square centimeters. cm, abbreviation for centimeters. So again, how many 8s would go into that 68? That would help me find that number. And I'm pretty sure you said 8. 8 should have been your answer. 8 times 8 equals 64. And that would tell me what the missing factor would be. Great work, students. Today we reviewed counting unit squares to find the area of a figure. We also learned that we can use multiplication to find area. We applied this knowledge to find the area of squares and rectangles to find the missing side lengths, and you did a wonderful job. In just a minute, I'm going to put the independent practice on the Elmo so you can do the same thing at home. I enjoyed being in your home today. Thank you so much, and I can't wait to see you on the next Tennessee at Home Learning Series for Math. Bye-bye.